A device that makes distant objects appear closer. Telescope. A telescope is a tool that uses lenses or mirrors to help us see faraway objects like stars and planets. Imagine trying to read a sign from far away when your eyesight isn't perfect. Just like squinting helps you focus and bring the details of the sign into view, a telescope uses lenses and mirrors to collect and magnify light, making distant stars and planets look closer. In both cases, the challenge is about enhancing perception. Whether by adjusting your eyes or using a telescope, both methods serve to bridge the gap between your current vision and the distant object you wish to see more clearly. Dark, flat regions on the moon made of ancient lava flows. Maria are large, basaltic plains formed by volcanic eruptions on the moon's surface. Imagine you're in your kitchen and you've accidentally overcooked a pot of soup, causing it to bubble over and spread across your stovetop, leaving a flat, dark stain. This bubbling and spreading is similar to how ancient volcanic activity on the moon caused molten lava to flow across its surface, eventually cooling and creating large, dark, flat regions known as Maria. Just like the soup spreading on your stovetop, the lava on the moon spread out and solidified, leaving behind these expansive dark areas that are easily noticeable from Earth. The 2 days a year when the sun is directly over the equator, making day and night equal. Equinox. An equinox occurs when Earth's tilt aligns the equator with the center of the sun, resulting in equal lengths of day and night globally. Imagine trying to perfectly balance a seesaw with two people of equal weight sitting at opposite ends. This moment of balance is similar to the equinox, where the Earth's tilt and orbit align so that the sun is directly over the equator, creating equal lengths of day and night. Just as the seesaw achieves perfect equilibrium when weight is evenly distributed, the equinox represents a point of balance in the Earth's journey around the sun, where light and darkness are distributed equally across the planet. Occurs when Earth's shadow falls on the moon. Lunar eclipse. A lunar eclipse happens when the Earth comes between the sun and the moon, blocking sunlight from reaching the moon. Imagine you're trying to watch a movie on your TV, but someone walks in front of the screen, blocking your view. This scenario is similar to a lunar eclipse, where the Earth gets between the sun and the moon, casting a shadow over the moon. In this analogy, the TV screen represents the moon, the person blocking the screen is Earth, and the light from the TV is the sun's light that gets blocked, causing the eclipse of your view. Occurs when the moon's shadow falls on Earth. Solar eclipse. A solar eclipse happens when the moon moves between the Earth and the sun, blocking sunlight from reaching the Earth. Imagine you're sitting in a room trying to watch your favorite TV show, but someone stands in front of the screen, blocking your view. This situation is similar to a solar eclipse, where the moon positions itself between the Earth and the sun, casting a shadow over a portion of the Earth. Just like the person obstructing your view of the TV, the moon blocks the sun's light from reaching certain areas on Earth's surface, creating the shadow that we perceive as a solar eclipse. The imaginary line around which Earth rotates, it runs through Earth from pole to pole. Axis. The axis is the line that Earth spins around, causing day and night. Finding the perfect balance when riding a bicycle can be a tricky challenge. Just as a bicycle needs its wheels to spin around their axles to maintain stability and direction, Earth rotates around an imaginary line, its axis, to maintain its orientation in space. The bicycle's axle acts like Earth's axis, providing a central line that ensures smooth and steady movement, much like how Earth's rotation keeps our days and nights consistent. Changes in the shape of the moon as seen from Earth. Moon phase. Moon phase is the appearance of the illuminated portion of the moon that we see from Earth as it orbits our planet. Imagine trying to watch a movie on a laptop screen while someone keeps adjusting the screen angle. Just like the movie's image appears differently depending on the angle, the moon's phases change based on the angle from which we view the illuminated part of the moon. In both cases, the changes in appearance are due to the perspective from which light, the movie's backlight or the sun's light on the moon, is observed, highlighting how perspective alters what we see. The motion of one body around another, like the Earth around the sun. Revolution. In science, revolution is the circular or elliptical movement of an object around another object or point. Imagine you're trying to stay in the loop with a group of friends, always rotating between each other's homes for gatherings. Just like you revolve around your friends' homes, the Earth revolves around the sun in a never-ending orbit. In this analogy, your group of friends is like the gravitational pull of the sun, constantly drawing you back into the cycle of visits, ensuring a stable and consistent pattern of movement, just as the sun's gravity keeps the Earth in its orbit. The turning of a planet on its axis, rotation. Rotation is the circular movement of an object around an internal axis. Imagine trying to evenly toast a marshmallow over a campfire without burning it. Just as you slowly rotate the marshmallow to ensure all sides get the right amount of heat, a planet rotates on its axis to ensure that all parts experience sunlight and darkness. In this analogy, the marshmallow represents the planet, the campfire acts like the sun, and the careful rotation mimics the planet's rotation, which allows for even distribution of light and heat across its surface. The darkest part of a shadow, umbra. The umbra is the fully shaded inner region of a shadow where the light source is completely blocked. Imagine trying to find your car keys in a cluttered drawer where everything seems to blend together. Just as the keys can be hidden in the darkest corner of the drawer, the umbra is the darkest part of a shadow where no light can reach. In both cases, the key and the umbra are surrounded by lighter, more visible areas. The clutter in the drawer, or the penumbra of the shadow, making them hard to notice without careful attention. A region of lighter shadow around the darkest part of a shadow, penumbra. The penumbra is the partially shaded outer region of a shadow cast by an object, like during a solar eclipse. Imagine you're in a crowded room trying to listen to your favorite song playing softly in the background. Just like how the chatter of people can drown out the music, leaving you with only bits and pieces of the melody, the penumbra is a region where light only partially reaches, creating a lighter shadow around the darkest part. In this way, the people in the room are like the light source, the music is the main shadow, and the overlapping sounds are the penumbra, a space where the clarity of the song is compromised, just as the light is partially blocked in the penumbra. The study of all things in space, like the sun, stars, and planets. Astronomy is the science of understanding celestial objects and the universe. Imagine trying to organize your closet, where everything from clothes to shoes is scattered all over. Just as you would sort and understand what each item is and where it belongs in your closet, astronomy involves categorizing and studying the sun, stars, and planets to understand their roles and positions in the universe. In this analogy, your scattered closet represents the vast universe, and organizing it is like astronomers studying space to make sense of the cosmic items, identifying the shirts as stars, the shoes as planets, and the hats as the sun, each with its own unique place and function. The attractive force between all objects that have mass. Gravity is a force that pulls objects toward each other, like how Earth pulls us toward its surface. Imagine trying to keep a messy room tidy, where every item seems to have a mysterious attraction to the floor. Just like how those objects seem irresistibly drawn to the ground, gravity is the force that pulls objects with mass towards each other, like the Earth pulling everything towards its center. In this analogy, the floor represents the Earth. The scattered items are the objects with mass, and their tendency to fall and stay put is akin to the gravitational pull that keeps us grounded. A large pit on Earth or any object in space created by an impact from a smaller object. Crater. A crater is a bowl-shaped depression formed when a meteorite or other object hits a surface. Imagine you're at a beach and you watch as a child throws a stone into the sand, creating a small depression where it lands. This scene is quite similar to how craters form on Earth or other celestial bodies when a smaller object, like a meteor, strikes their surface and creates a large pit. Just as the stone disrupts the smooth surface of the sand by transferring its energy into the ground and pushing the particles aside, a meteor impacts a planet's surface, transferring its kinetic energy, displacing material, and forming a crater. A telescope that uses concave mirrors to reflect and focus light from distant objects. Reflecting telescope. A reflecting telescope is a device that uses mirrors to gather and focus light from stars and planets for viewing. Imagine you're trying to see your reflection clearly in a spoon. Just like a spoon's concave surface gathers and focuses light to show your face more clearly, a reflecting telescope uses a concave mirror to collect and focus light from distant objects. In both cases, the curved surface, the spoon or the telescope mirror, captures scattered light and concentrates it to a point, allowing you to see the details more clearly. A telescope that uses convex lenses to focus light from distant objects. Refracting telescope. A refracting telescope uses lenses to bend light and make distant objects appear closer and clearer. Imagine trying to read a sign from far away that appears blurry and too small to understand. Just like how you might use a pair of binoculars to bring the sign into focus and make the details clearer, a refracting telescope uses convex lenses to gather and focus light from distant objects, making them appear larger and more defined. In this analogy, the binoculars represent the telescope's lenses, which both serve the purpose of collecting light and focusing it to help us see distant details more clearly. All the wavelengths or frequencies of electromagnetic radiation. Electromagnetic spectrum. The electromagnetic spectrum is the range of all types of light energy, from radio waves to gamma rays that travel through space. Imagine trying to find the right radio station while driving, with each station offering different music, news, or talk shows. This is similar to the electromagnetic spectrum, where each station represents a different wavelength or frequency of electromagnetic radiation, providing various types of information, such as visible light, radio waves, or X-rays. Just as you tune your radio to match the frequency of your desired station, different devices and technologies are designed to interact with specific parts of the electromagnetic spectrum to receive or transmit the right type of information, highlighting the spectrum's diversity and utility. The path of one body around another, like Earth's orbit around the Sun. Orbit. An orbit is the curved path that an object takes around a star, planet, or moon due to gravity. Imagine trying to keep a hula hoop spinning steadily around your waist. Just like the hula hoop needs the perfect balance of speed and rhythm to stay in motion around your body, Earth needs the right balance of speed and gravitational pull to maintain its orbit around the Sun. In this analogy, your waist represents the Sun, the hula hoop is Earth, and the rhythmic motion you use to keep it spinning is similar to the gravitational force and momentum that keep Earth in its orbit. a device that burns fuel and expels gas in one direction to move in the opposite direction. Rocket. A rocket is a vehicle that moves by pushing gas out one end to propel itself forward using Newton's third law of motion. Imagine you're trying to push a heavy shopping cart that just won't budge until you lean against it with all your might. Much like how you push backward to get the cart moving forward, a rocket works by expelling gas in one direction to propel itself in the opposite direction. Just as your backward force on the cart results in it moving forward, a rocket burns fuel to forcefully expel gas backward, which then pushes it forward through space. An object that moves around a larger object in space, like the moon around Earth. Satellite. A satellite is an object in space that orbits another larger object, like a planet. Imagine you're trying to keep a hula hoop spinning around your waist. Just like the hula hoop needs the right speed and direction to keep circling you without falling, a satellite must travel at the right velocity and path to orbit around a larger object like Earth. In this analogy, your waist represents the planet, the hula hoop is the satellite, and the spinning motion is the satellite's orbit, demonstrating how balance and momentum keep both in consistent motion around their central points. A spacecraft that carries scientific instruments, but no human crew. Space probe. A space probe is a robotic spacecraft that collects data from space to help scientists learn about different celestial bodies. Imagine trying to get groceries from a store that's too far to walk to, and you can't go yourself. Just like how you'd send a friend with a list of items you need, a space probe is sent out with a set of scientific instruments to gather data from space without needing a human crew. In this analogy, the grocery list represents the scientific objectives. The friend is the space probe, and the groceries are the data collected, highlighting how both scenarios involve sending something or someone else to gather what you need when you can't go yourself. A reusable craft that can carry crew and cargo between Earth and space. Space Shuttle. The Space Shuttle was a spacecraft used to transport astronauts and equipment to and from space. Imagine you have a sturdy suitcase that you use for every trip, carrying your clothes and essentials back and forth without needing a replacement. The Space Shuttle operates on a similar principle, as it is a reusable vehicle that ferries astronauts and equipment between Earth and space repeatedly. Just like the suitcase, which is designed to endure multiple journeys while securely transporting your belongings, the Space Shuttle is engineered to withstand the rigors of space travel and return safely, ready to embark on new missions while carrying its valuable human and technological cargo. An artificial satellite on which people can live and work for long periods. Space Station. A space station is a large spacecraft in orbit where astronauts live and conduct scientific research. Imagine trying to create a cozy, functional home in a small studio apartment. This challenge is similar to designing a space station, where every bit of space must be efficiently used for living and working over extended periods. Just as you have to carefully arrange furniture, organize storage, and ensure that your studio apartment meets all your daily needs, engineers must meticulously plan the layout and systems of a space station to provide astronauts with everything necessary to live and work in the confines of space. The pushing force exerted by the engine of an aircraft or rocket. Thrust is the force that moves a vehicle forward through air or space. Imagine trying to push a heavy shopping cart with a stuck wheel through the aisles of a grocery store. Just as you exert force to overcome the resistance and move the cart forward, an aircraft or rocket engine produces thrust to propel itself through the air. In both cases, the effort applied to move an object from one place to another is akin to the thrust, where your pushing force is like the engine's power. The cart is like the aircraft, and the friction from the wheel is similar to air resistance. A device that detects and records radio waves from space. Radio telescope. It is a large antenna that listens to signals from space to study stars, galaxies, and other cosmic objects. Imagine trying to listen to a friend's quiet whisper in a loud and bustling coffee shop. Just as you need to focus intently to pick out your friend's voice from all the surrounding noise, a radio telescope is designed to detect and record faint radio waves from space amidst the cacophony of signals on Earth. In this analogy, your friend's whisper is like the radio waves from distant celestial objects. The coffee shop noise represents the Earth-based interference, and your focused attention parallels the radio telescope's ability to isolate and capture those faint cosmic signals. A building that contains one or more telescopes used to observe space. Observatory. An observatory is a place where scientists use telescopes to study and learn about the stars and planets. Imagine you're trying to listen to your favorite radio station, but are surrounded by static noise and interference. This challenge is similar to how an observatory works, where the goal is to capture the faint signals from distant stars and planets amidst the vastness of space. Just as you need a well-tuned radio to filter out noise and focus on the clear broadcast, an observatory uses telescopes to isolate and magnify distant celestial signals, allowing astronomers to observe and study the universe beyond.